Eric. Good morning, everybody. Just by show of hands, just an informal poll. How many of you are ArcGIS users or have used ArcGIS? Oh, excellent. Good, good. Second, how many of you have a drone or have used a drone or thinking about it? Well, let's start with have a drone or use a drone. Okay, a couple of you. Now, how many of you are thinking about using a drone and potentially getting it? Okay, well, hopefully maybe after the presentation today, a few more of you will start falling into that second camp. I'm an imagery guy, been around a long time. Not quite as long as Deb, my friend, my colleague, but we've been imagery folks for a long time. And there's an old saying out there, you know, that when your only tool is a hammer, the whole world's a nail. Well, when you're an imagery guy, I can tell you these drones are a brand new hammer that are extremely exciting. And as soon as I saw what they were capable of doing, I go, I got to get one of those. And so fortunately, I had this little slush fund in my PayPal account that my wife didn't know about. And so I was able to get this. Where'd you get that drone? It's like, don't worry. But I got my drone sitting over there. And a group of us got together at ESRI and said, you know, we can probably do something with this. And we started playing around. And very quickly, we realized that we had a whole new window on the world. And that window, especially with these lower cost drones, is all about what I call microgeographies, smaller areas. You know, there's just so many areas out there that are just not cost effective to go out and buy a World View 4 image, you know, satellite image of, or, you know, rent an aerial company to go out and fly with an aerial camera. But here is an aerial imaging system that you can keep in the trunk of your car that you can afford with your own little slush fund if you know how to do it right with PayPal. And so it was very exciting. And what we found out as we started working with it is that A, the information that comes off these things is extremely high quality. B, the technology has gotten to the point, look, I never bought a radio-controlled airplane because I knew that I was going to smack it into the ground. I have only crashed my drone once, and that was in my basement, and that's a long story. But they're so easy to fly because of the technology. And then finally, they're just extremely accurate. And I'll talk a little bit about accuracy as I go through the presentation. So, and it turns out that as we started moving forward with this, the very first site that we flew for a mapping mission was Oatlands. I don't know if any of you have heard of Oatlands, National Historic Trust, out by Leesburg, you know, Plantation House. And there's a lot of reasons why we ended up at Oatlands. I'll explain a little bit to you, but it was essentially about the only place in the DC area worth imaging that we could get approval from the FAA to fly. You know, because it's always a struggle with those rules, and I'll show you that a little bit. But it actually turned out to be a very good test site. And so we went out there, and this is now about a year and a half ago. We went out there and started flying Oatlands. It took us 2 days to fly the whole thing, and you can start seeing some of the results. The map, extremely high resolution, 2-inch resolution, very highly accurate ortho photos of the Oatlands area. That entire map there is made up of 72 images that have been ortho-rectified and then seamlessly mosaic and stitched together to make that map. And I'll show you the resolution of that in just a minute. The other thing we were able to get is generate a 3D site model of the particular area of interest. Because when you do the ortho-rectification, as Deb can explain as a photogrammetrist, you actually have to extract the elevation information out of the stereo imagery. And so with that elevation information, you can actually create a point cloud, similar to what you can get from LiDAR, but it's a photo-derived point cloud. And so that point cloud becomes a mesh, which you can then in turn create a 3D model out of. And fortunately, all the ArcGIS software, the drone to map software, allows you to do this very quickly. Well, quickly depending upon how fast your computer is, but that's a different story. But and then the other area, which is extremely interesting, is that once you build the mathematical models behind those images, each of those images can have a transform assigned to it. So it mathematically knows where each of those pixels are. So you can use the software to go in there and actually do very precise measurements on the actual photos that you took from the drone. So if you want to measure the areas of the roofs or the sides of buildings or windows, whatever, you can all do that photogrammetrically inside the imagery that was captured with the drones. So the three things: map, model, and measure. That's really what we're trying to do with Drone to Map and the capabilities that it provides. Here's just an example. You can actually, count the gravel in the driveway, see the tiles in the roof. I could zoom in even more in this. The garden was imaged on the second day, but you can't even tell where the seam lines are. So this is the measure of the quality that you can get off these drones. This obviously isn't all 72 images because I've zoomed in to look at some of the area, but that is a mosaic probably of about, I'd probably say about 15, 16 images right in that particular area, all stitched in. And the nice thing is the software is totally automatic, so it does all this for you. You just load it up and off it goes. Here's the example of the 3D mesh. This is available. You can go to ArcGIS Online, do a search on Oatlands, and you can get a 3D model, and you can spin that around, zoom in, zoom out, fly all around in it in a 3D type environment. The nice thing is, just recently added is a one-button publish from Drone to Map into ArcGIS Online for all the 3D models. So you're creating 3D web models extremely quickly with the software. So we designed our software with kind of four operational patterns that we were looking at. The first one is obviously this 2D mapping, imagery mosaics. You saw an example of that with Oatlands. Another thing we can do that I didn't really talk about here, and this is a project I'm working on right now with Chesapeake Conservancy, good friends of ours. We actually are getting a 4-band camera that looks in the IR, so we can do things like vegetation analysis through NDVI and those types of things. So that's also a part of this 2D mapping, is this vegetation land cover classification product. As far as elevation products, I talked about the point clouds, but you can make shaded relief maps, contour maps, whatever you want from the high resolution elevation. And of course, then we get those obliques, and then if you're interested, you can actually use the motion imagery, the video, and use that directly in ArcMap and relate that back to your image map. So you can actually see in the video exactly where you're looking on your map and vice versa. So that's another interesting product. It's separate from Drone to Map. Those are our full motion video tools. But Drone to Map is the one that you want to use particularly for your 2D mapping and 3D mapping, static mapping, I should say. So not all drones are the same. ESRI has a number of partners working in the drone field. Each one of these offer different advantages. I think the key thing to remember is that there's really two types. There's fixed wing, which are kind of like a conventional aircraft, and then there's your copters, typically quadcopters. There's some octocopters, there's some other ones, but typically these copters. And generally what we've found in practice is that if you're mapping an area that's less than 500 acres, you can do that very well and easily with a quadcopter, with one of these copter drones. But once you bust that 500-acre limit and want to get a bigger area, you're much better off switching to these fixed wings because they can collect a lot more ground in a single battery-operated flight. Of course, that means you got a lot more imagery to process, but that's where you want to go if you're going into the bigger areas. And I wanted to bring a drone, for those of you who haven't seen it, just to show you some of the key capabilities. So here's my Phantom drone. It's a quadcopter. This is the camera right under here. It's the camera that comes with it, and it's on a mount. And this thing flies around. This is the typical size of the battery for the drone. It takes about an hour and a half to charge up the battery. It gives me about 30 minutes of flight time on this particular drone. And then this is the controller. And you can see that the controller comes in two parts. And most of the commercial drones out there are just like this one. You have your flight controls, which allow you to spin it around, make it go up, fly forward, backward, those types of things. But typically your Android or your phone or your iPad is used to control the camera itself. So you can fly it here, and then you'll take your pictures, record video through the camera itself. And so that's how the two work together. And then you think, well, how do they communicate? Well, this little device is actually a router Wi-Fi network. And so just like the Wi-Fi inside your house, it creates a Wi-Fi network between your phone, your controller, and your drone. And those are in constant communication with each other, you hope. and yes, and then this is what passes all the information back and forth. So you can actually see in real time exactly what the drone is seeing. So when you want to take a picture, you know exactly when to do it. So there's some of the key capabilities. But I also encourage you to look closely, if you go down the drone route, at the types of cameras involved, because these are very important. I mean, the drones are going to do what the drones are going to do, but the cameras are important for the type of information you want to collect. If you're interested in that vegetation analysis, you want to do something like this Mica red edge sensor. It's a 4-band sensor, so it gets that IR and it can do that vegetation mapping very well. We found out that this Sony camera is actually extremely accurate for survey level quality. We've also found out, like the GoPro and the camera that comes with typically comes with the drone, they're actually pretty dang good. You know, the difference between the high Sony and the GoPro, it turned out we were able to get accuracies of about 1 foot in 3 dimensions with the GoPro, but the Sony we were able to get down to 1.5 inches in 3D. So if you're doing some of your archaeological work, working on buildings and stuff like that, go with a little bit better camera. But if you're just doing general broad areas for maybe environmental monitoring or something, that GoPro that comes with your drone will actually do pretty good and get you some really good accuracies. One other thing I'd like to point out, this Altavia Nova, that's another great company we work with. They're from Florida, and they map the Everglades. That drone can land on water, which is really great when you think about it, because those fixed-wing drones need kind of a landing area. And when you're out monitoring natural resources, a lot of times you don't have a lot of clear open areas to land. So that can land right on water, and it's totally waterproof, and it's very versatile. So there's a lot of creative energy going on into these drones. And this is a very technical diagram. You know, afterwards Deb can explain this, but this is just lens accuracy and lens distortion. And you can just see how some of these things work. That Sony, you can see how accurate it is, no error distortion. The GoPro has that problem because it's a fisheye lens. You know, you get that wide angle look. And so you get a lot of distortion out on the periphery, but inside it's pretty tight. What was interesting about these Phantoms is they're actually a slide shutter capability. So they take excellent pictures, but there's a little bit distortion going out to one edge. So you just got to look at these things and be a little bit careful. The other thing that's critical is ground control, especially if you want that accuracy. One of the things that we've been able to do is use some type of very accurate handheld device. This is a Leica Xeno running the ArcGIS collector app. And it can go down and it can get ground control points that are within, you know, a few inches. And that's exactly what you want. If you're okay with 1 or 2 foot accuracy, the GPS on the drone is going to be accurate enough for you. But if you want to get that 1 inch, 2 inch high degree of accuracy in 3D, you want to drop some good quality ground control points that you use. And of course, it helps to have some of those markers on the ground that when you fly over the imagery, you can actually see those markers. Another innovation thing, look closely, this is actually a digital marker, and it actually has a GPS inside of the marker, and they broadcast to the drone exactly its geographic location. So the whole goal is to make this as highly automated as possible. You don't have to get that fancy. I use soccer cones that, you know, I used to use to mark my kid's soccer field for my ground control point markers. You just got to get something you can see in the imagery. The whole processing workflow, something we call TCPED. That stands for tasking, collection, processing, exploitation, and dissemination. Right now, ESRI relies on our partners for the T and the C. We don't make drones, and because we don't make drones, we don't make the tasking software that goes along with the drones. And I'll explain a little bit about that. But what Drone to Map does is the processing. It takes that raw imagery off that drone, processes it so you can use it inside your GIS. There is some exploitation in the software that you can use to do different types of products like the NDVI, your 3D models, do some measurements, those types of things. But your heavy duty exploitation comes if you use ArcMap or ArcGIS online. And finally, we built the tool so it can publish, as I said before, directly into ArcGIS Online. So that gives you an automatic dissemination capability. If you don't have ArcGIS Online, if you have Portal or just a server, it will also publish there as well, just with a single button, both all the 2D and the 3D products. So we have this very strong dissemination capability. There are rules about flying drones, especially as a commercial operator. Up until very recently, August 29th, they just introduced something called Part 107, where they relaxed the rules a little bit for commercial operators. They actually allow trained pilots to fly drones to the same degree that a hobbyist could fly a drone. Isn't that amazing, you know? I mean, literally, until Part 107, a trained pilot who was flying commercial had more restrictions on them than a hobbyist flying a drone. So they've leveled that playing field a little bit, and they've made it much easier. You no longer have to be a licensed pilot to commercially fly a drone, but you do have to get certified through a special drone training program that they have. There's a number of courses online that you can go and take and do that. The basic bottom line, and I don't want to go into details on all those regulations, but just about anybody in this room could take those online courses, pass this test, and become a drone pilot right now. So that's the good news. There are still some limitations, especially here in the DC area. You can see this, you know, ArcGIS plot up here before. The big round circles, those are airfields. Can't fly within 5 miles of an airfield, except for Ronald Reagan National Airport, 15 miles, which means we need special permission to fly Mount Vernon. So you can get it, but you just have to request it from the FAA in order to do that. The other limitation that you used to have is that you couldn't fly within 500 feet of a person who didn't agree to be flown around commercially. That included if they were in their car or in their house. So when we did a plot of, you know, the counties around Northern Virginia, and we put a 500-foot buffer around every single road, every single public place that was available, that really starts limiting the areas that you can fly without doing that. With Part 107, if the person's in a protected thing like a car or a house, there's more ability to fly around that person. If they're out in the open, though, you still got to get their permission if they're within 500 feet. So keep that in mind as you start planning your projects. It's good to have permission from everybody that you're flying your drones around, you know, to let them know that you're doing that. A couple things to consider is when you go out and start doing your collection. If you want to do that 2D, kind of 3D mapping, you fly a pattern that we call mowing the grass. The goal behind mowing the grass is to get good overlapping stereo in a consistent pattern over the biggest area that you want to collect. And so essentially the drone just goes up, goes down, comes back, goes back and forth until it gets that overlap. And overlap is critical. What we're actually recommending for very accurate results is 80% overlap fore aft. So as the drone is flying along from forward to backwards, there's an 80% overlap in the photos that it takes. And then side to side is a 60% overlap. On the other side of the coin, if you want to do 3D site models around a building, we recommend two different orbits, a lower one and a higher one, where the camera's looking down at a steep angle and then a less steep angle for the two orbits. And that's how you collect a good 3D model of an area. You just dump those images then into Drone to Map, and it figures out all the mathematics for you and comes out with the calculations, depending on how you want to fly. Now, the good news is that all our partners have developed some very nice flight management software, so you can program these two different modes right into the drone. And so, for instance, if you want to mow the grass, you just do a stretchy box over the area that you want to map. You can rotate that stretchy box so it fits, you know, pretty much in the area, your area of interest, and then you just hit the go button, and the drone just takes off, goes around, and hopefully comes back and lands, and you get your maps. And it's really phenomenal. You know, it was like, first time we did a really big mapping mission automatedly, we were all excited, and then we realized there was nothing to it. You push the button, the drone goes, and you barely see it as a little dot on the horizon, and it buzzes back and forth, and then 20 minutes later it comes down and lands right next to you, and you go, woohoo, and it's all good. It's all good. The key thing here is let the robot be the robot. When we did the Oatlands imagery, we did it all manual because they didn't have good flight control for that particular drone yet. And it was extremely time consuming. It took us about 8 flights over 2 days to get the whole thing. And we were manually doing it and trying to line things up. And that was probably about 20 acres. My most recent project, we did about 90 acres down in North Carolina, and it took us 30 minutes. So, and we just let the drone go out and fly its area of interest using the controlling software that came with it. So take advantage of those, you'll get much better results. As we say with Drone to Map, we want it to be very simple. Fly the drone, run the app, get the map. It runs on Windows. It does not require ArcGIS desktop. You know, if you can spend $1,500 on a drone, we don't want you to have to go out and spend, $15,000 on the software. So we made it as a standalone app that's very low cost. You can actually go on our website right now and download it for a free 60-day trial if you want to use it. Do that after you buy the drone, because then your clock won't tick out on you. The nice thing about that is this also includes one license of ArcGIS Online, so you can immediately publish web maps that come off your drone and disseminate those. So it's a good thing to try. As I said before, the 3 main products we get off this are our 2D image maps, our ortho rectification. The software automatically color balances all those photos and stitches it together as a single mosaic. That becomes a GeoTIFF file that you can publish as a web map, or you can use in other software that can read and understand GeoTIFFs. It also creates all the 3D elevation products, a LAS file, which is a point cloud file, if those of you are familiar with point clouds. These 3D mesh models, which a lot of modeling software packages can use, we can actually bring these 3D models into our City Engine product, add textures, do other things to create complete 3D mapping, similar to what Mount Vernon's done in the past. The other product that we can build are these 3D PDF files. So you can just create a 3D model and then PDF it to someone, and they can spin around it all day long. So it's kind of a nice little capability. And then these smart inspection photos with the mathematical transform built into them. Example of some projects. I've been having fun. How many of you have been out to Mallows Bay kayaking? It's a fun place. Yeah, I think you're a kayaker, right, Eric? So if you ever have a chance, go do this. It's really fascinating. This is just a little bit down the Potomac River, kind of across from Quantico on the Maryland side. There's about 60 old World War I wrecks out there that were surplus ships at the end of World War I, so they just dragged them all there. They burned them down to the waterline, and there they've been sitting for the past 100 years. Fascinating place to go, go out and see and kayak. We took our drones out there, decided to have some fun. You can see our kayaks up there in the upper right. We're waving at the drone. But this is the types of things and the images you can collect. You don't have that type of visibility into a site that you get from the air. You just can't see the same thing when you're down in the water. It's amazing. It's kind of like an osprey up there. It can look down and penetrate that water depth, so you can really see the detailed information. This is a 3D project that we did for University of Southern California, USC. This is the USC, the Rose Bowl Stadium. We did this in support of the LA Police. They were looking at drones for a public safety type issue. We're creating 3D models around LA at extremely high resolution. That is a point cloud, a texture mesh point cloud taken from a drone. And then this last project, I'll go in a little bit more detail. This was the Wrightsville Beach project we did. As you can imagine, this is extremely expensive waterfront property. And every few years that beach erodes out, the Corps of Engineers has to come in and renourish the beach itself. And they constantly monitor it to see how bad the erosion is. And so they just send a survey crew out there, and they do what they call transect lines. They walk down the beach 100 yards, run a transect line. Walk down the beach 100 yards, transect line. Well, we took our drone out there to see what kind of results we could get. And this is the Drone to Map software. We just set up a project. We dropped some ground control down along the beach area, and this was after the collection part. And then we actually flew the area. And this 3D map kind of shows you right here, this is the flight lines that we took, and this is all the images that were collected. This is the 3D model that resulted. You can see the elevation information, and I don't know if you can see it kind of clear there. These are the tire tracks from us driving on the beach with this little John Deere thing with the generators in it. We were able to map the tire tracks in 3D. The results were just amazing. The accuracy that was amazing. This is what we're able to do. 71 acres. It took us about 28 minutes to fly and then about 4 hours to do all the processing of the imagery. We dropped 14 full ground control points, surveyed in XYZ. We had a total of 195 images, or about 1.25 gigabytes, and we ended up with a resolution of, looks like about 1.21 inches. And then when we created the elevation data, we created 104 points per square meter. By these, I mean 3D LiDAR point cloud points. The previous most high-resolution LiDAR over this stretch of beach was 2 points per square meter. We took it to 104 points per square meter to an accuracy of about 1.5 inches in 3D. So that's pretty phenomenal with the results that we were able to get. There's those tire tracks you can see on the beach that we were able to map. And then McKim & Creed, who was our partner, they're a big engineering company down in the south, they just did some benchmarks against this. And what they did was a comparison between conventional surveying and surveying with the UAS. Turns out that it's 30% less expensive and it captures significantly more detail in a lot less time. The Corps also drove a terrestrial LiDAR along the beach at the exact same time we were flying it. And it turned out that we were within 2 centimeters of that terrestrial LiDAR that they were flying along the beach. And it was still much cheaper, much more cost effective for us to collect it with the drone than that terrestrial LiDAR. And then you do a cost comparison with an aerial LiDAR. The UAS is 60% cheaper based on their estimates than going out and doing it with a conventional aircraft. So there's really some cool benchmarks that can be done there. They're cost effective, they're extremely accurate, and they can certainly support the missions you want to do. So I encourage you, check out our Drone to Map page. If you're interested, Chesapeake Conservancy and ESRI is giving a Drones for Conservation webinar this Thursday. Go to our website and do a search, Drones for Conservation, and you can find out more. Working with Chesapeake Conservancy, they flew this great area over on the eastern shore, and they're going to talk about all the ways that they feel as a conservancy they can start using the drones for environmental monitoring. So I think it'll be a very good presentation. So. With that, are there any questions I can answer for folks?
Yeah, we have about 5 minutes for questions. If you have one, raise your hand and we'll give you a mic so the people watching the live stream can hear the question too.
Hi, I'm Kim Williams. I'm with the DC Historic Preservation Office. And I have a question about the interpretation, sort of cultural interpretation of sites and how you may work with the property or the property owners to pursue that. So in the case of Oatlands, for instance, are you all working with Oatlands Plantation at all so that they might be able to benefit from that incredible mapping of their site? And are they excited? Do they have ideas about how they might be able to interpret their cultural landscape or historic buildings?
Absolutely. As a matter of fact, that was all part of the agreement that we worked out with Oatlands. All the data that we collected, we shared with them and made available. And so it's their information to use. That was our very first pilot project that we ever flew. So we are still learning on how best to do it. But absolutely, that was definitely part of the agreement, and with the National Historic Trust, because we had to go to that level to get permission to fly it since it's one of their properties. But I would strongly encourage you that, because that's a real benefit of doing this, is that you can go to these sites and they can truly benefit from the imagery, the information that you collect for them as part of a bigger picture. Hopefully that answered your question.
More of a technical question. How does the, say for example, the mowing the lawn, how does the drone account for wind speed or bursts of wind or even obstructions from birds or overhead wires?
So what's going to happen is that before the drone takes off, it's going to figure out every point it needs to take a picture at to meet the specifications of your collection. The overlap, the altitude, et cetera. And it will specifically fly to that point before it takes that picture. And that's the beauty of that quadcopter. It can, you know, I've seen it, when we were flying down at Wrightsville Beach, we had a steady wind of 12 knots. I've flown it as much as in 25 knots, and that thing will actually crab into the wind to actually position itself exactly where it needs to be to take those pictures. The nice thing is it doesn't have to be perfect. The reason that we're able to get away with the photogrammetry that we're able to get, if you do standard aerial photography, there's very expensive equipment that you have to get the extreme accuracy. The difference is that we're flying at 200 feet with an extremely short focal length camera. They're flying at, you know, 15, 20,000 feet with a long focal length camera. So for them, if they have the slightest distortion in that aircraft that they're not compensating for, that imagery can be way, way off. Whereas the drone, it's at such a low altitude that it'll still be tight even if it's crabbing a little bit or off the wind. But they do a remarkable job of going to those points that they want to collect.
Kurt, you just suggested that you're flying at about 200 feet. Is that what you have found to be the optimum elevation? And for a half an hour flight, how much disk space do you need for storage of the images that you're collecting?
Yeah, so we found it, you know, it depends on the resolution that you get out of your imagery, right? So it turns out 200 feet is actually good if you want to get about 1 or 2 inch resolution. If you're able to go up to a 4-inch resolution, maybe you want to fly at 400 feet. And very clearly, the higher the resolution those images, the more images you have to collect to cover a certain area, and the more disk space that can take up. I think on the slide I had the total file size. I think for the Wrightsville Beach project, yeah, that's about what it was. We did that in 2 missions, easily in 2 missions. So generally you can do about 50 acres in a mission, depending on how your area is. The nice thing also about this, you can see it, you can see the 2 flight patterns we basically flew. We flew up and down the beach, and we also flew this back and forth down in the spit area of the land here. The goal was to avoid the houses, because at this time we didn't have permission to fly over people's houses or other things. One trick about that 500 feet is that it also includes the altitude. So if you're flying at 400 feet, it's the hypotenuse, right? You know, that's your distance from your target, so that's something to keep in mind. But you know, disk space isn't the real problem, but the more imagery you collect, the more processing time is required. And so we found to have a little bit of a beefier system with multiple CPUs works out extremely well. The software is scalable. It'll ramp up and take advantage of as many CPUs as you can, especially as you're doing that 3D extraction. That's a real number crunching beast. So it helps to have powerful systems there. Other questions?
What's the FAA regulation for height?
So the question was, what's the FAA regulation for height? Right now, you can, as a commercial pilot, without any extra permission, you can fly up to 400 feet. Anything above 400 feet, you have to have special FAA permission to do it. So the question is, for these types of flights, do we have to notify the FAA that we're flying this? If it's not restricted airspace, if you're within those requirements of you're not flying within 5 miles of an airport or other restricted airspace, 15 miles of DC, if you're staying underneath 400 feet, you're generally good to go. You don't have to file anything special or anything for the FAA. You can just go out and do it. Once you start, if you go in, and that 5 miles of an airport means there's an active control tower. So if it's just a little airport that's down and it doesn't have an active control tower, you don't have that 5 mile limitation. But once you start going inside those restricted zones, or you want to fly higher, or maybe you want to fly out of line of sight, then you have to file a special request for the FAA to get permission for those types of flights. So if we were to fly Mount Vernon per se, we would have to get special permission from the FAA because Mount Vernon is within that 15 miles of National Airport. The good thing is they're fairly quick at turning those things around, and probably for Mount Vernon, you would state a use case, and once you had that use case, you would get a kind of a, I won't say a permanent exemption, but a long-term exemption, so you could do multiple flights underneath that exemption.
I was just to add to that specifically. So we've looked at it from Mount Vernon. We also have we're one of only like 60 in the country where there's actually a specific no-fly zone right over Mount Vernon that was put in about 40 or 50 years ago to keep sightseeing planes and helicopters away. So we're actually looking into getting an exemption and think we'll be successful because we can guarantee that there are no other planes that we might run into because they're not allowed to fly here. So, so yeah, it may just be, you have to look for your specific place and find out what the restrictions are.
Good point. Great.
So with that, I think we're ready for lunch. I'm sure Kurt would be happy to be bugged over lunch with questions about stuff. So seek him out if you have more questions. So lunch is going to work here. We have the boxed lunches.